Hello, ladies and gentlemen. Welcome to the first lesson in the unit on integration or antiderivative. Anti-differentiation or integration, the terms are used pretty much interchangeably, is where we go from the derivative and try and find our original function. Okay, so if you think of it, the reverse of doing the derivative, the reverse of the power rule, the reverse of the chain rule, it makes it a little easier to understand. And there's a lot of words on this page, and we'll talk about those words in class. I'm not going to go through all of them. I don't even want to read all those words. Let's go about it. I just want to do math time. So there's this fancy formula here and all that. So we're going to just pass that by, and we're going to talk about the step-by-step process by which you go from the derivative, f prime of x, back to your original f of x. So if we look at this example, our derivative is 2x, just 2x. 2x, that's it, 2x. The exponent here is a 1, we don't write it. So it's 2x to the first is our derivative. So we take the exponent of the x term, which is 1, and we add 1. So we will now have an exponent of 2. Then whatever your new exponent is, you divide by that. So the exponent here is 1, we add 1 is 2. Then we divide the whole thing by 2. So when we're done, it looks like this. Exponent of 1, add 1, that's how I got that 2. Whatever this new exponent is, you divide by that exponent. So we have 2x squared over 2. When you clean that up, you simplify the expression to x squared. But we don't know if there's a constant after that, like a 7, a 3, a 5, any number, -6. We don't know what that is yet. And we'll get to finding that out in the next couple of days, or maybe after Christmas vacation. So you'll have to deal with the suspense right now of not knowing what c is. So in the absence of being able to figure that out, we just tack on a c at the end. So the original function was f of x equals x squared plus some unknown c. And like I said, the suspense of what that value of c is may have to wait till after Christmas vacation. I know the suspense is going to kill some of you. It's just going to be eating at you, that you are going to be constantly thinking, what is c? What's the value of c? But we'll get to that. So let's go through it again. You take your derivative, in this case it's 2x. You look at the x term. You see what the exponent is. In this case it's a 1. You add 1, and that's how I get an exponent of 2. Then I divide everything, or divide that expression by my new exponent of 2. So let's take a look at a couple of examples. The examples are on the back of the page. So if we look at the first one, we're given our derivative is 3x. So when you look at this, the exponent here is 1. So our new expression will be 3x squared. And we have to divide by 2, because our new exponent up here is 2, you're going to divide by 2. And so when we clean that up, it's 3 halves x squared plus c. Don't forget to add the plus c at the end, that's important. Okay. Let's take a look at the next one. Our exponent here is 1. So we're going to change the exponent from 1 to 2, and then divide by 2. So we have x squared over 2 plus c. And typically we would write that 1/2 x squared plus c. Okay. Try not to leave it in this fraction form. Make the fraction the coefficient. So instead of x squared over 2, make it 1/2 x squared. So now, look at this, big time. We have an exponent of 2, 4x squared. So the exponent of 2 becomes a 3. Then we divide by 3. So we wind up with 4x cubed over 3 plus 8. And we clean that up a little bit. It's 4/3 x cubed plus 8. Okay. Hopefully right now everybody's seeing the pattern. Let's look at the next one. I'll tell you what, why don't you guys close the screencast, try the next one. look at what we've been doing with the exponent, adding 1, dividing by the new exponent. So pause the screencast and try that one and come back and check your work. Hopefully everybody paused the screencast and tried that one on their own. So let's take a look. The exponent of 3 becomes a 4, dividing by 4. When we clean this up, 4 over 4 is 1. So the original function here was x to the 4th plus 6. Okay. And let me stop here. If we look at this, these are all self-checking problems. Because if we take what we have on the screen here, x to the 4th, and we take the derivative of that using the power rule, you multiply 4 times the coefficient of 1, you get 4x, and you take your 4, subtract 1, and you get 3, which is 4x cubed. So once you find your original function, you can check to make sure you've done it right, because if you take the derivative of what we just found right here, that derivative should be the problem you were given. Okay? So let's do one more. And this one has 2 terms, but you handle each term separately. So if we look at this, it's 5x to the 4th. So now what we know we're going to do is change the exponent of 4 to a 5, dividing by 5. And then the next one, the exponent of 2 becomes a 3, and you divide by 3. So the first pass looks like this. Exponent of 4 becomes 5, divide by 5. Exponent of 2, add 1 to 3, divide by 3. And then when we clean this up, our original function was x to the 5th plus x cubed plus c, some unknown c. And like I said, we'll get to determining the value of c. I'm guessing we won't get to that for Christmas vacation. So you'll have to remain in suspense about c until after New Year's. So thank you for tuning in to the latest edition of Math 12R Screencast. This is the first lesson in the unit on integration or antiderivatives. So I'll see everyone in class. Thank you for tuning in.